And so now we're continuing to work electrostatic problems symbolically, so no numbers. So okay, and so here's one that I want to work for you, and it's good. We work it out. We work it out with numbers, and so it's good for you to see me work it out with just symbols. Okay, basically what I do is I have okay, so I sort of did this right in my very first video, and it's a humid day so you couldn't really see this, but basically I've got an aluminum sphere on a string, and I've got another aluminum sphere on a string, and they are both charged, and they have equal and opposite they have equal charges. They have equal charges, and so they repel each other, and so there's a little gap in here. And so, well, what do I know? I know they have a mass, and they've got a charge, and the string has a length, L, and there's an angle between them, theta. So, the string has a length L, and the balls possess two quantities, which we're going to call mass and charge, and they have the same mass. They both have the same mass, and they both have the same charge. Okay, well, how are we going to crack into that? There doesn't seem to be a lot of information. Well, let's start making some right triangles here. Okay, so I'm going to say that this distance here, I'm going to find this distance here for just 1 second, and I'm going to find that distance, and that distance is going to be the sine of theta divided by 2 is equal to, I'm going to call this r over 2 divided by L. So I'm going to say r over 2 is equal to L sine theta divided by 2. And then I'm going to say that the whole thing, this whole distance r is going to be 2L sine theta divided by 2. Okay, so I found a radius. Now I'm going to say, I'm going to draw another thing where I'm going to just put it as forces. So here we've got distances. Now I'm going to talk about forces. Now here I've got there's a force. There's going to be three forces. There's going to be the force due to gravity, there's going to be the force electric, and there's going to be the tension in the string. And if that ball is hanging out if that ball is just hanging out without moving, the force due to gravity, the electric force, and the tension in the string, they should all add up to 0. And that again should be theta divided by 2 up there. Now my force gravity, I know force gravity, well let's just write this. I'm going to say the tangent of theta divided by 2 is going to be the force electric divided by force gravity. Okay? So I have tan theta over 2 is equal to force electric times force divided by force gravity. Still, where am I going with this? Well, let's start plugging in what we know about force electric. Force electric is K Q1 Q2 over R squared. And we can simplify that down since we know the Q's are the same. It's K Q squared over R squared. And I know that, I also know that R is 2L over sine theta divided by 2. So I'm going to probably just leave that for a second. I'm going to come back to it. Force gravity is going to be mg. It's just going to be the mass of the ball times the acceleration due to gravity. So now I have tan theta divided by 2 is going to be equal to kq squared over r squared over mg. So I'm going to have, if I just sort of get this, tan theta divided by 2 is k q squared over mg r squared. Okay, and that's where I'm going to fill this page. Those are what I really need to hold on to, and we're going to go over into the next sheet, and I'm going to copy those down. Okay, so now we're going to throw this into there. So I'm going to say tangent of theta divided by 2 is equal to k q squared over m, that's a g, and then 2l sine theta divided by 2, all of that squared. Okay, so then finally I'm not really finally, I'm going to make that 4 mg L squared sine squared theta divided by 2. Okay, and I think I'm just going to sort of, might as well just put it all on one line. So I'm going to have 4 mg L squared sine squared theta divided by 2 tan theta divided by 2 equals k q squared. And while I'm at it, why don't I just solve for q, so I can just say something equals something. And you guys, I'm going to go through this really quick. I'm going to say q is equal to L sine theta divided by 2 times the square root, 2L sine theta, let me get that again. Q is 2L sine theta divided by 2 times the square root of mg tan theta divided by 2 all over k.